Good morning again, grade 10s. Welcome to another lesson on exponents. I wonder if my backlight will work out. I hope it does. Today we're doing exponential equations, and you have seen exponential equations since grade 8, and you've seen it in grade 9, and you most of the time hated exponential equations, but unfortunately it is something that you have to do still. And I hope it makes a bit more sense this year that you've seen it so many times. Very quickly, what does it mean if I have an equation? It means I need to solve for something. So that would be the first thing, solve for something, okay? And it also means that I have an equal sign running down the middle, okay? It means I have a variable, let's call it x, equals a value, okay? I want to get a value for the variable. Why do I do this with equations? Because I want to get a value for a variable that balances it out. So say, for example, if I had 2x plus 1 equals 10, okay, let's make it equals 11 rather. I want to know what variable do I put in there so that my left-hand side and my right-hand side balance or equate. Hence the word equation, okay? Variable on one side equals a value. And you're always asked to solve. So what makes an exponential equation a special type of equation? Because you see many different equations. Well, an exponential equation is the variable is in the exponent. What does that mean? That means I give you 2 to the power of x equals 8. Okay, here is my equation, equal sign running down the middle. I ask you to solve for x, get a value for x that is going to balance out this equation. Okay, can you remember how we do this? The first step would be to make the bases the same. So I choose 2 because I can write this as an exponent with a base of 2 because 2 to the power of 3 gives me 8. Once I do that, I can ignore the bases and I end up with x equals 3. And that is true, because if I had to replace x with 3, so if I had to write 3 over there, 2 to the power of 3 is 8, and 8 equals 8. Hence, I've balanced out the expression, or the equation, rather. Okay. So there were many things that you were taught last year. Where do kids make the mistake? If I just go back to the same example, kids divide by 2. For some bizarre reason, they divide by 2 and they think that that cancels, dividing this by 2, and they tell me that x equals 4. That is the incorrect way to do that. Please don't do it that way. Please remember that if I have a fraction, so 1 over 5 to the power of x, this becomes 5 to the negative 1 raised to the power of x. Take this positive power up. I don't want these fractions. Also remember that if you ever, for some reason, come up with something like this, 1 to the power of x, remember that 1 to the power of x is 1, because 1 raised to anything stays 1. 1 raised to 100 is 1. 1 raised to negative 100 is also 1. So, if you ever get 1 to the power of x, the result is 1. The other thing that you must remember is that if I had 2 to the power of x equals 1, okay, what is the trick here? If it equals to 1, writing them as the same bases, 2 to the power of 0 gives me 1. So x would be 0. Okay, so those are things that you learned from the previous years. Let's start with example 1. Example 1 says solve for x if 6 to the power of x equals 36. So this is example 1. Okay, like bases, I choose this to be 6 squared because 6 squared is 36. I'm not changing the value of the equation or this value. I'm just writing it in a different form. That's all I'm doing. Why? So that I can ignore the bases and x equals to 2. Okay, that would be your first one. Example 2 says solve for x if 8 to the power of x plus 4 equals 4 to the power of 2x plus 9. Okay, cool. So I need bases to be the same, and the only way I'm going to rewrite 8 and 4 in the same bases is if I change it to a base of 2. Because I know if I rewrite 8, I can rewrite 8 as 2 cubed, and I'm left with x plus 4. And then I can rewrite 4 as 2 squared. And then I have 2x plus 9. Only when the bases are the same can I equate them. Hence, I can see how are they equal to one another. We learned this week. What do? I distribute this in and I distribute this in. So I'm left with a base of 2 to the power of 3x plus 12 equals 2 to the power of 4x plus 18. Cool. So remember, that now our bases are the same, so I can just hide the bases, okay? And when I hide the bases, I'm left with 3x plus 12 equals 4x plus 18. And oh my word, this is a linear equation. X's to one side, numbers to the other side. I always take my x's to the left-hand side, but if you took your x's to the right hand side, it's no problem. I'm just going to bring the 4x over and I'm going to have 3x minus 4x, and on this side I'm going to have 18 minus 12, so I'm left with negative x equals negative 6, therefore x equals to 6. How does x equal to 6? If you're still, I'm jumping a step, but you divide by negative 1, you divide by negative 1. That would be example 2. Okay, I'm just constantly checking that the lighting is okay on the video. Let's look at example 3. It says solve for x of 3 to the power of 2x equals 1 over 9. Okay, cool. I don't want this fraction, but I also want them to have the same bases. So I'm quickly going to rewrite this 9 as 3 squared. So this is what I'm changing. I'm changing 9 and I'm making it 3 squared. I'm not putting it in brackets because 9 doesn't have any associated exponent with it. So I'm just leaving it as 3 squared, okay? I don't want the fraction, so I take the fraction to the top and I end up with 3 to the power of 2x equals 3 to the negative 2. Okay, like bases, ignore the bases, and I'm left with 2x equals negative 2. Divide both sides by 2. And I see that x equals negative 1. Solving for x. Okay. Example 4. It says solve for x if 2 times 25 to the power of x equals 250. There's many ways you can do this. You can go and rewrite this as a base of 2 times 5 to the power of something. Another easy thing you can do is you can just divide this by 2 and divide this by 2. Why am I doing this? Because this here has the power or the exponent with x. So this is what I want to solve here. It has the x. So if I divide by 2, that cancels because this is a monomial divided by a monomial. I end up with 25 equals 125. And that seems quite easy to do because this I can see I can write as the same basis in terms of a base of 5. So instead of writing 25, I can write 5 squared to the power of x. And instead of writing 125, I can write 5 cubed. Again, I'm not putting it in brackets because this doesn't have an exponent, so I won't need to do any distributing. Okay, the distributing comes in here, and it'll be 2 times x. So I've got 5 to the power of 2x. Let me write it in black. 5 to the power of 2x equals 5 to the power of 3. Like bases, ignore the bases. 2x equals 3. Solving for x means dividing by 2 and dividing by 2. And I've got x equals 3 over 2. And that is your answer for example 4. Halfway, 4 more examples to do together. Okay, example 5 says solve for x if 4 to the power of x plus 6 equals 1. And I already showed you the trick. I still need to make them the same base. How do I write 1? How do I write 1 as a base of 4? Well, it's 4 to the power of 0. Again, I haven't changed anything. I'm just writing it in a different form. And then I can just equate my exponents. X plus 6 equals 0. Taking the 6 over, x equals negative 6. Cool. Example 6 says solve for x if 125x times 25 to the power of x minus 2 equals 25. Okay. Right, so we can change this all into powers of 5. Well, bases of 5, okay? 25 squared does not give you 125, so you can't make this 25 squared. So instead of writing 125, I'm going to write 5 cubed. I keep it in brackets because it's got this exponent on the outside. Okay? 25 I can write as 5 squared. Again, I keep it in brackets because of x minus 2. And then I can rewrite this 25 as 5 squared. No brackets because you can put it in, but there's no exponent on the outside. Okay, distributing in, I'm left with 5 to the power of 3x times 5 to the power of 2x minus 4 equals 5 to the power of 2. What do I notice is happening on this side? Like bases that are multiplying. So what can I do? Keep the base, add the powers. So keep the base of 5, adding the powers. The only like terms in the adding of the powers would be the x's. So I have 3x plus 2x, which is 5x minus 4, because the 4 doesn't join with anyone, equals 5 to the power of 2. Okay, so like bases on either side of the equation, ignore the bases, write down your exponents and solve. Solving for x, I take the negative 4 over. It becomes a plus 4. So I end up with 5x equals 6. What do I do to get rid of that 5? Divide by 5, divide by 5. Those cancel, monomial over monomial, and then x equals 6 over 5. If you wanted to say 1 and 1 over 5, you can. But either way, you get your full marks. Okay, 2 more examples that we're doing together. Example 7. Looks like this. It says solve for x if 3 to the power of x equals 1, 5 times 2 to the power of x. Okay, what is my problem here? My problem is that I cannot multiply these two things because they are not like bases. So I can't multiply these two things. And my other problem is I've got an x on this side, I've got an x on this side. If you think of our other equations, my x's were always on one side, and then I had another base on this side that didn't have an x. So I'm going to get all my x's to one side. And how would I get this x over to this side? Okay, well, what's the opposite of timesing? I would divide this by 2x because that and that cancels, and I divide this by 2x. So I end up with 3 to the power of x over 2 to the power of x. So that solves my problem of getting all my x's to one side. Okay, but here I've got this decimal of 1, 5. How can I relate 1, 5 to these two things that have exponents of x's? I can't make these two things into the same bases at all, okay? What can I do with that 1, 5? Do you agree that 1, 5 can be written as 3 over 2? 3 over 2 is 1 1/2. 1 1/2 is 1, 5. Okay, so I'm going to change writing that 1, 5 into a fraction, because then very easily I get 3 over 2. And what can you see the value for x is? 1. Because 3 to the power of 1 gives me 3, and 2 to the power of 1 gives me 2. Okay. Yes, so x is 1. Remember, x as the same value. So what same value gave me this out? They had to have the same value. Okay, that took a bit of thinking. And then we've got last example, example 8. It says solve for x if 25x minus 1 over 5x plus 1 equals 24. Okay, all the x's on one side, but here I can't cancel anything yet because I've got a polynomial over a polynomial. How do I move this from a polynomial to a monomial? I have to factor on it, remember? So I'm going to rewrite this as a product of its prime numbers. So This 25 can be written as 5 squared to the power of x minus 1 all over this I'm staying is 5x plus 1. Okay, equals 24. Distribute this in, and I have 5 to the power of 2x minus 1 over 5 to the power of x plus 1 equals 24. Now, we spoke about this in the previous lesson. What does 5 to the power of 2x mean? 5 to the power of 2x means I had two 5s that were multiplied together, and I had two x's. Why? Because the x plus the x, that's my rule, x plus x, gives me 2x. Okay, so if I keep that in mind, and I rewrite that as 5 to the power of x times 5 to the power of x minus 1 over 5 to the power of x plus 1 equals 24. Okay, my other problem is, okay, so that's what you would think we may do. But what is my problem? My problem is I can't move this to a monomial because I don't have an HCF to take out. Same at the bottom, there's no HCF to take out. So let's retract a bit, okay? If I can't take out an HCF, what can I perhaps do? What is my next form of factorization? So it was HCF. After HCF is dots or trinomial. That's what you learned in grade 9. And then we also had cubes. Those are my three methods of doing factorizing. Okay, so if I can't do HCF, let's look at dots. Okay, two perfect cube squares divided by an equal sign. Equal sign. This is a perfect square. Is 5 to the power of 2x a perfect square? Well, yes it is. Remember, what makes something a perfect square is if its exponent is an even number or divisible by 2. So if I had a to the power of 2x and I asked you to find the square root of that, you would tell me that ax is the answer because I divided this by 2. So why wouldn't it work if 5 may not be, the base may not be a perfect square, but because it's an exponent, or because it's a power, the exponent is makes it a perfect square. Okay, so if we had to do dots at the top, 2 brackets, plus minus, can't do anything at the bottom, I'm just putting it into brackets to make it a monomial, because that's all I actually can do if it's a monomial, if I can't factorize it this way. If I had to find the square root of this number and divide this by 2, what happens? I get 5 to the power of x, 5 to the power of x, and then I get the square root of 1, which is 1 and 1. Oh my word, what do I notice? Monomial over monomial, okay? What can I do? Cancel things that look exactly the same. So I can cancel that and I can cancel that. That means I'm left with 5 to the power of x minus 1 equals 24. Okay, let's take the 1 over. It becomes a plus, and I'm left with 5 to the power of x equals 25. Okay, very simply, to solve for that, you could already see that 5 squared gives me 25, but how do I show it mathematically? Well, 5 to the power of x is the same as 5 squared. I've just changed how 25 looks. X equals 2. Okay, so that's quite a tricky one. That is the end of the examples that I'm going to show you. You then have exercise 5 to do, and the more you do, let me see if you can see, the more you do, the better you become. We will confirm inside the Instagram post which ones you should focus on. Perhaps this is a challenge for you, should be the ones you're looking at. Okay, cool, grade 10s. Have a good day. See you tomorrow.